Hey, hello guys, welcome, welcome, Vandanam, Namaskar, and today we are going to see continuity, okay? So, already I have uploaded a video where about NCERT continuity, okay? It offed. Isn't that it had offed? I don't know what is the percentage of charge, I don't even know whether did I charge it or whether I did not. Okay, so coming to here, which is continuity. As I said already, I have uploaded the video for continuity of our NCERT, but for some higher level we are going to discuss. Okay, already I have uploaded completely for inverse trigonometry. A to Z we have discussed little bit higher order than NCERT. Then also for relations and functions we have uploaded, and there will be one shot video completely for relations and functions as I've left rational functions. And in inverse trigonometry till we have to cover domain, but that's not in our NCERT questions, but questions are being asked. Okay, but questions are being asked very well from that. We will also discuss that one. Then now we are going to see only continuity. Okay, continuity and differentiability is a very great chapter. So in that, first we are going to discuss about continuity. It's about just 1 hour video. Okay, the total concepts are very small. We will just complete them within like this, and we will go to differentiability in our next video. Okay. There might be 2 videos for differentiability, as differentiability isn't a small topic. Okay, it is a very big topic. And also even differentiability, there is applications of derivatives. We have to also see that. So okay, so continuity. What is continuity? Okay, what does the word continuity mean? First, in terms of general English, we will discuss. Then we will come to our mathematical concepts. Okay, if a graph of a function does not have any sudden change, or abrupt also you can use. Okay, any sudden change, then it is known as a continuous function. See, in terms of our general English, we will discuss. Okay, let's keep that this is a function. Okay, what is this function? You can actually represent it as 2 different functions. The x cube is also going to have the same graph. Okay, x cube is also going to have same graph. Okay, and also tan theta is also going to have the same graph. So you can say anything, but if you represent here minus pi by 2 plus pi by 2, then if you represent infinite, then it will be tan theta. If you don't represent such sorts of things, then it will be x cube. Okay, so I'm going to consider this as x cube graph. Okay, you can see that there is no change in this graph, even though there is change. Okay, even though there is change, that change is very slow, like it's very slow. Okay, it's actually increasing. You can see that this graph is increasing, and more than that this graph does not have any change. It's very slow. Okay, even if the change is there, the change is very slow, that you can very easily say that. Okay, but when you take graphs like this, okay, when you take some graphs which are like this, you can see that this particular point is empty, which means there is a sudden change over here. Okay, there is a sudden change, and this point, okay, let us take that this point is over here. Okay, the point which should be over here is actually here. Okay, the point which should be here is here. I will give a different color so that you can differentiate. Here it has a sudden change, and also you can say this definition as like this. In order to determine, just by looking at this, whether is this continuous or not, to draw this graph, actually there is a general concept, that is, you need not to lift your pen while drawing this graph. See, this is a continuous graph, right? You need not to even lift your pen while drawing this. You can just draw like that itself. Okay, so that point you need not to write, but you can just remember. But whereas here, while drawing this graph, you have to lift your pen. Okay, so this is this can be anything. Okay, this can be anything. I have not given a specific name, but this is going to be continuous. Okay, and then this one is actually going to be discontinuous. Okay, so now actually whether in order to determine whether a function, okay, whether a function, how to determine, okay, so how to determine whether a function is continuous or not. Okay, this is a question, very common question. This literally with this point which I'm about to say, you can solve 99.9 questions based on this concept itself, that is limit. Okay, limit x tends to -0, which is left hand limit. Okay, left hand limit should be equal to right hand limit, which should be equal to the function. I know nothing makes sense, but I'll just write this. Okay, so f of minus x should be equal to limit where x tends to 0 plus f of x plus, which should be equal to f of x. Okay, this is the important concept that I said. With this you can actually solve 99.9 sums. Then you can ask, why should you watch remaining part of the video? Well, to be very accurate. Okay, I have given some shortcut tricks. To use those shortcut tricks, you can use it. Okay, see here, this one. Okay, I will explain why did we get this formula. It's very simple. Take this one point. Okay, take this one point which is over here, and take this one point which is over here. Okay, and take this one, and you are going to take this one. Okay, so you can see that. Okay, let me keep this point. Okay, this point as L1 point. Okay, and let me keep this point as L2 point. And sorry, that is also going to be L1 only. Okay, let me keep this point as L2 point. Okay, by limit concept, you all know that. Actually, let's also keep that there is this limit existing. Okay, there is this limit existing. So if limit exists, then what? For this function, there is limit existing. Okay, you can keep like that. Now you are sure that the limit exists. So that means what? This point and this point will be equal. Okay, so for better explaining, I'm going to keep this point as 2 itself. Okay, 2, and this is 3. Okay, let it be like that. And as I said that there is this limit that is existing. So that means L2 is equal to L1. Okay, so I'm going to rewrite now. I'm going to rewrite the name now. Okay. So now this is going to be L1. Okay, so this is L1. Now actually this is L1 and this is also L1. If the value of L1 is equal to L3, that means for these values L3 is also same. That means for these values, if the value of L3 is also same, then that means what? Then this will be a smooth curve. Then that means, according to mathematics, then this point will be, okay, then this point will be here. Okay, so if that point is over there, that means that it is a continuous graph. Okay, so that means this function is going to be a continuous function. Okay, I hope everything is clear. So in order to say whether it is actually continuous or not, in limits itself we have studied what is actually limit, what is the definition of limit. A value that is being approached by a function is what the definition of limits, right? So here this is what the value that is being approached by this function. Okay, this is what the value that is being approached by a function. You can keep like that, and then you see, so this is L1 and this is you can keep it as L2 also, but since these two are same, so I've kept it as L1. Okay, I hope everything is clear. That is why you are giving like this, and if this condition is being satisfied, then okay, then that means it is continuous. If this condition is not satisfied, then it is not continuous. Okay. Now we are going to discuss next another concept, which is one-sided continuity. great. That's oft. So let this be point A and let this be point B. Okay, so I'm going to draw this graph now. Actually, this one concept in applications of derivative, you will be seeing a similar graph. Okay, in there you will be discussing applications of derivatives, you will be discussing, and also in relations and functions. In order to find whether a function is 1 or not, I used a similar graph like this, and I said that when you are having graphs which is like this, okay, there is actually calculus method. There are totally 5 methods in order. We saw only 3. Okay, so according to our knowledge, there is only 3 different. There are only 3 methods. First is our NCERT method, that is x1 is equal to x2. Then secondly, it is our graphical method where we will be drawing a horizontal line in order to determine whether it is 1 or not. Then at last but not the least, it is our calculus method, which is a very golden method. That is, we'll be having some graph like this. Okay, so you can see that this is a graph. Okay, well, I know that this is not a perfect graph. Okay. In this case, what you are going to do is, first you have to remember this. This is a particular interval. Okay, so you are going to check whether this function is continuous or not only at this particular interval. Okay, well, there is actually some different concepts also where for interval also we are going to find whether it is continuous or whether it is not continuous. So first here I have to say one point, that continuity can be checked only for a single point. Okay, by human, we are humans, right? Robots can do anything, machines can do anything, but we are humans, it is actually a single point thing. Okay, this total concept itself is actually suitable only for a single point. So continuity can be checked only for a single point. It can be checked only for a single point, but we also have an interval. Okay, that also we will be saying. Okay, so come here now for an example. For the instant, we are going to have, like, there is a graph. Okay, there is a graph that exists like this. Okay, like this the graph exists, but even though it exists, but since you are going to check from A to B, okay, till this point only you are going to check. So that means you are not going to consider this one or this one. Okay, you are not going to consider this one and this one. You are going to check only whether it is continuous or not from A to B. Okay, so now what you are going to do, we are going to first check here. Okay, so at x is equal to A. Okay, then also at another point, that is at x is equal to B. Okay, see, now what I'm going to check is, first you have to know that this is left hand side, this is A minus, which is left hand side, and this is A plus, this is B minus, and then this is B plus. So as I said earlier, you are not going to consider B plus and you are not going to consider A minus. Okay, so both of these points you are not going to consider. A plus and B minus you are going to consider. Okay, and also you are going to consider point A and point B. So that means f of A you are going to check. Okay, f of A you are going to check, and then f of then limit where x tends to A plus, f of A plus you are going to check. For this one you are going to check. Then here also, like the same thing only, where f of B you are going to check, which is equal to limit x is equal to B minus, f of B minus you are going to check. Okay, so for these points you are going to check. Then if you check at those points, then it means this particular, in this particular interval, this continuity is actually continuous. Okay, so it is actually not interval, you are actually only checking at A. Okay, for point A when you are checking, it's not for an interval. Okay, it's not for an interval, it is for a particular point, where for this point you are checking. So for this point what you are going to do is, you are going to put values from this side and here. Okay, some limits concept also you have to know in order to understand this lesson. Limits is very important. Okay, and also for here you are going to put some values from here and then at this point, then you are going to check. So yeah, now let us do one sum. Actually I have already taken one sum and I've kept, but it's in the wrong notes. No, once again. Where is my sum? Let us also discuss one-sided continuity. Continuity at an interval. Then we will go to one sums. Okay. At an interval, you are going to check. So, after seeing this point, then we are also going to see the difference between continuity at an interval and continuity at a point which is one-sided. That we are going to see. So, same graph you have to take here also. Graph is what's same, but other than that, concept has some differences. We will also understand those differences. So, let this be one point and let this be another point. Okay, let this be A and then let this be B. This is point A and then this is point B. Okay, so here also the same concept only, no matter whether graph exists from here to here or from here to here, it does not matter for us. Okay, you are not going to consider that one. Only you are going to consider the graph which is between point A to point B. Okay, so continuity at an interval itself is actually of two different types. First is you have to understand some concepts about interval. So interval. See, in interval you will be normally using two different types of brackets. What are they? There will be open brackets and then closed brackets. Okay, so brackets which are like this and brackets which are like this. Okay, so in case of open brackets you'll be having like this, which is A comma B. In case of closed brackets you'll be having brackets which are like this, A comma B. Okay, so then what is the difference between open bracket and then closed bracket? Here you will be considering every number that is between A to B. Okay, that is between A to B. That means if there are some amount of numbers, there will be definitely infinite amount of numbers between two different numbers. Okay, this is something which we have studied in our very lowest standard itself. Okay, so between A to B, there will be some there will be a lot of numbers, right? So you are going to consider those many numbers, but by excluding A and B, you are not going to include A and B. Okay, that is what this notation is. When you include A and B also, when you are having this A and when you are having this B, in that time you will be using this bracket. Okay, so this is in your 11th standard and in your bridge course they will be teaching, or in wavy curve method also they will be teaching, as wavy curve method is a very important concept that we use in our 12th standard and in our 11th standard. Okay, let it be. So continuity, a function is said to be continuous if, okay, in an interval. So wait, they are asking you to check whether it is continuous or not in this. Continuous or not in this particular interval. Okay, so that means, what does it mean? That means it should be, if it is continuous at this interval now, then that actually means that that function, okay, that function is continuous at each point each point between A to B. Okay, between A to B. What does it mean? That means, as I said, that there will be some numbers between A and B, right? In each and every number, you have to put and see whether it is continuous or whether it is not continuous. So that is why I said that we cannot do that as, but some mathematicians have found some way, and we are going to see some points over there also. Okay, so it is continuous. A function. What is this? What is this? A function is continuous at each point between A comma B. If it is continuous in the interval of A comma B, then that means it is continuous at each and every point between A comma B. So at each and every point, it is going to be continuous between A comma B. That is what it means. I hope it's all clear. I am saying the same point repeatedly, but with a different tone only. Okay. Then, in order to determine whether it is continuous or not by using this bracket. Continuous or not for this bracket. The first condition is that it should be continuous. Okay, it should be continuous at A comma B. That means for this open bracket, first it has to be continuous. So except A, okay, except including this number from this point to this point, it should be continuous excluding A comma B. Okay, excluding A and B, except that number. So now what you are going to do is, now we are going to use this one-sided continuity, which is used for single points. Okay, not single point, this point and this point. So you can take it as double point, or when you're taking only A, you can use it as single point. So that is what, this is like a point concept, but this is for an interval concept. Okay, that is first difference. And here the second difference is that here you have involved intervals, and after involving intervals only you are going to check whether it is continuous at point A and at point B. But here you are directly going to check whether it is continuous at point A and point B. That's it. Okay. So exactly same formula only I am going to write there also. At x is equal to A, and then at x is equal to B. This color. Okay, so what are we going to use? We are going to use at x is equal to A. Now this is A plus, okay, and then this is B minus. So A plus and B minus. So limit which tends to A plus, okay, f of x minus should be equal to f of A for here, and for here limit where x tends to B minus, okay, f of x, wait, B minus, here plus should come, yeah, here plus should come, and here minus should come, okay, minus is equal to f of B, okay, is equal to f of B. This concept is alone one-sided continuity, remaining other than that you have learned just now. Okay. So discontinuity of a function, that also we are going to see now. Then we will be seeing some other sums. Okay, then we will be seeing some other sums. Discontinuity of some functions we shall discuss. Okay. Where is it? Here it will be, I think. Okay, so now what you are actually going to do is, we have discussed lots of functions and including their graphs by our lesson, okay, with our lesson called relations and functions, right? In that we have discussed very clearly what a relation is, then also what a function is, then we have discussed about types of functions like modulus, all those things we have discussed. Then on to we have discussed, coming to relations, we have discussed about transitive, reflexive and symmetric. So by using all those, I know it is soft, but speaking like this is giving me a kick than speaking without it. Okay, so now we are going to see each and every graph, and then we are going to compare like whether it is continuous or whether it is discontinuous. Okay, and it is, since it is 20 pages and this board is not as smart as you all are, it is taking some amount of time. Now it has got it. So first I have to check whether this is the place that I have drawn quadratic function. Okay, so first check whether is this continuous or not. You can see that there is no abrupt change. There is no abrupt change. It is very smooth. So yes, this is continuous. Okay, so quadratic function is continuous, and also linear function is also continuous. Then cubic function is also continuous. Okay, all these functions are continuous. Next is exponential. You can see that exponential does not have any abrupt change. Okay, also this one, see, exponential is having two different graphs. So you can see, so in both of those graphs it is continuous only. Then coming to our logarithmic graphs, logarithmic is here, no? So these two are logarithmic graphs. Here also it is continuous. Logarithmic graph is also continuous. Okay. Then after this we have relations and functions too. Now we are going to see modulus function. See, modulus function graph is also continuous. You can see that it is like just like a V, okay, which is V. There is no abrupt change, but even though there is one sharp corner, but we don't remember this sharp corner. Okay, this sharp corner we will be using in one more concept also. That is actually modulus of a function. Okay, function. Okay, a function within a function within that function. That means one function will have another function inside that. There, this sharp corner little bit we will be having a touch. Okay, and it is 17. Oh, here also it is 28. No. Here it is 17. Okay, so that is why it is loading this much. Next is greatest integer function. You can see here, okay, over here it is discontinuous. Just see here, this point, at this point, at this point, at this point, here at all these points, okay, at every integer, it is discontinuous. Okay, not every point that I'm saying, because don't worry, I will give that. Okay, next is signum function. You can see here, okay, here it is completely discontinuous. Okay, exactly 0. Okay, exactly at 0. There it is all at integers. Here also it is discontinuous at integers. Okay, at integers. Then what is this? Okay, this is all sum that we have discussed. This is also sum that we have discussed. Hereafter we won't have any graphs. Do we have? No, we don't have. Just look at this. This is what? This is actually our sine and this is actually a cos graph. Sine graph and cos graph. Remember, sine and cos, all trigonometric functions, not only sine and cos, all trigonometric functions are continuous at their respective domain. Okay, are continuous at their respective domain. I don't know that I have deleted it. Now we are going to go into continuity. Okay, back to our continuity. Okay, so we discussed for every function. Okay, now what we are going to see is, again we will be going into our continuity, but you have to please wait. I cannot edit. I don't have that much of time to edit. But I will edit some videos, okay, because I know that I've made those videos very awful. Okay, so please load fast. Okay, so I'm going to do some sums. Sorry, some sums. Okay. I don't know why am I speaking like this. Now, first sum that we are going to do is f of x. Actually, this is a piecewise function, where that means one function will be having two different formulas. Okay, that means within one function there are two different functions. That is composite, but similar to that only. Okay, so x square minus x minus 6 whole divided by x plus 6, then k. Okay, when x is equal to x is not equal to 2, you have to use this, and when x is equal to 2, then you have to use this. Okay, what they have said is, actually this is second sum we are going to. Okay, this is the second sum that we are going to do. Before that, we are going to do another sum. Okay, it is continuous. It is continuous at x is equal to minus 2. Here minus should be coming. Okay, then k is. Okay, so before this one sum I'm going to do.